Good morning everyone, Dr. Nat here. So we are going to talk about pictorial drawings. But before that, I would like to remind you about orthographic projection or orthographic drawing that we have discussed in earlier lectures. If you have not watched them, please go and watch those first. So we know that the orthographic projection or the orthographic drawing, we get it from the six principal plane or the six principal plane that can be front, bottom, right, left, top, and also rear or at the back side. And I also told you that given that you have three views or multi-view of the object, you have like the front, the top, and the right side, draw the 3D object or draw the 3D view of the object. So the 3D view of this object is actually called pictorial drawings, and this is what we're going to talk about today. Okay, alright, so first thing is we need to know the different types of pictorial drawings. So we have the first one called isometric. I've talked about this one quite a number of times, but not in detail. Number 2, oblique, and number 3 is perspective. Alright, so here is an example of oblique. Oblique is over here. This guy over here is oblique. And oops, my pen is not working. Never mind. So oblique, as you can see over here, it is parallel to the x-axis, and it has some angle over here. We don't know what the angle yet is. And this is an isometric, whereby the angles A, B, and C is equal. Sometimes they are not equal, but most of the time we would use angles that are equal for isometric drawing, and the angles we will talk about them later. And this is a perspective drawing. The perspective drawing is the closest to what we view using our human eyes, right? We don't see objects like this. I mean, we do, but we have to tilt it a little bit. But in reality, this is what we see in our daily lives, which is the perspective view. And the perspective view is very skewed, or it is foreshortened considerably. So what exactly is isometric drawing? It is a type of axonometric pictorial drawing. Pictorial describes the 3D view for which the angle between axes equals 120 degrees. So look over here, you have between axes is 120 degrees, between axes 120 degrees, and between these axes 120 degrees. And the scale used is full scale, which means that if your object is 10 meters, then you would, is 10 centimeter, then you would draw this as 10 centimeter. Okay, so use the full scale. Isometric axes can be positioned in a number of ways to create different views of the same object. So this is our axis. It's a 3-axis like this. We can also use the axis down here and tilt our object like so. This is called the regular isometric, and this is called the reverse axis isometric. And this one, you tilt the object by 60 degrees. It is called the long axis isometric, and this is called the long axis isometric as well. You have that 60 degrees. It's the same thing, but just flipped. But we will use the regular isometric for our class. Okay, regular isometric is the most common type. Alright, so true length distances. So for isometric drawing, we know that the angle must be 120 degrees between axes, and it uses true length distances. And true length distances can only be measured along isometric lines. That is, lines that run parallel to any of the isometric axes. So this is our isometric axis, 1, 2, and 3. So anything that goes along these axes is the actual true length distance. For example, I can say, oh, this is the actual distance, this is the actual distance, this is the actual distance. It's not foreshortened. But anything that is not on the axis can be foreshortened. Can be foreshortened. So it's not going to reflect the actual scale. So this is also isometric lines because it is parallel to the axis. Okay, so in this case, we have our isometric axis. The isometric axis is always like this, and anything that goes within the axis or within the plane, you call it as isometric planes. So this is between the two axes, isometric plane. This is between the two axes. This is also an isometric plane. This is between the two axes that is coming from the isometric axis. This is also known as isometric planes. Okay, so this is a non-isometric plane because it does not come from the isometric axis. So you can't, it's really not aligned with the isometric axis except for this part. This part is aligned to the isometric axis, but this guy over here is not. So it's not a isometric plane. But this one is, this is a plane originating from the isometric axis, therefore it is an isometric plane, even though it looks a little bit weird, but it is an isometric plane. So in isometric drawings, hidden lines are usually omitted unless it is absolutely necessary to describe the object, meaning to say the feature that is portrayed by the hidden line is very necessary to execute the function. So sometimes you don't need it, sometimes you do need it. For example, the hidden lines is necessary for details. Without the hidden line, you wouldn't know that there is a wedge behind this L-shaped block. And for whatever reason, this wedge or this rectangular block is very important. Maybe it holds the object in place or whatever that it does. So it is necessary to have it in the isometric drawing as a hidden line. But typically, if it's not important, you can just omit the hidden line, or you can just omit whatever that you can't see. And center lines are drawn for showing symmetry or for dimensioning. Okay, so this is your center line to show symmetry. Okay, usually you don't draw it if it's not symmetrical. Normally they are not shown, and again, this is you only use it if you really need to highlight that it is symmetry. Okay, so this is the dimensioning for isometric drawings for production purposes. It's very neat. As you can see over here, the 15 is all dimensions and nodes should be unidirectional. Unidirectional meaning to say they are how do I say this? It goes from left to right, left to right, left to right, left to right. They are all at the same angle. The numbers are all at the same angle despite the lines not being at the same angle, right? So they are unidirectional, reading from the bottom upward, and outside the view. Okay, I think my explanation was better. So it's just like they have the same orientation. The text is all the same orientation. Now, there is another type of dimensioning. It is for illustration purposes. Now, in this case, the orientation is not the same, as you can see over here. It's not like how we would read this text. It's not the same orientation. This is all the same orientation, right? This is not. This is it follows the plane of which it is describing the dimension. So this is 15 describing this guy over here, the 20 describes this guy over here, and this 20 describes this plane, and this 60 describes this plane. So they need to be parallel to the plane that they are describing. Dimension lines, extension lines, and lettering are all drawn in the plane of one of the faces of the object. Okay, so how do we construct isometric drawings? So again, we start with our axis. The axis must have an angle of 120 degrees. So this is our first step. The second step is to draw your block. Draw your block or draw your surface. For this is what we're doing. This is what we have, our front, top, and right side view. And we know that this block will be within the dimension of width, height, and also the depth, right? So we are trying to imagine that this whole object will fit in something that has some height, some width, and some depth. So these are the key values that I need to start with to draw my isometric drawing. So this is the first thing that I'm going to do. I have my width, I have my height, and I draw my depth. And now I connect all of this to make one box. And then I draw in the details. Okay, again, you start with the angle, your axis. Axis has to use 120 degrees between axis. And then find out what is your height, width, and also depth. Like the largest size for your entire drawing, and use that as your block to start with. And then you draw in the details. And I'm not going to go over the details because this takes some time and it takes some thinking. So I want you guys to pause this video, look at it, and try to do it yourself. Okay, so from the right side view, we have this ladder looking thing, and we have this ladder looking thing, and there is a hidden line, which means that there is a plane that is not adjacent to these stairs. Okay, so use your knowledge that you have learned from orthographic projection and orthographic drawing to construct this isometric drawing. Alright, so what if you have non-isometric lines? What do you do? So remember that we started with an axis, and then we draw a block, and then we fill in the details. And we fill in the details according to the isometric axis, right? But what if we have something that is not on the isometric line? So our drawing becomes slightly harder. So this is what we're working with. This is our front view, this is our top view, and this is our right side view. Remember that true length distances can only be measured along isometric lines. That is, lines that run parallel to any of the isometric axis. Therefore, if you were to draw the slanted plane, this inclined plane, in your isometric drawing, you are not expecting it to be true scale. So it will be foreshortened a bit or more. Depends on how, it depends on the surface. Okay, so that is something to take note of. Everything that is within the isometric axis will be true scale, but anything that is non-isometric, it will be foreshortened. Okie dokie. Next. So for isometric drawings, what if you have curves? So the oddball previously was, what if you have a non-isometric line? And we know that you would get the true scale. But what if you have curves? So a way to draw that is to use the offset coordinate method. You can look this up in your textbook, but I won't go over it. We're not going to cover it in our syllabus, but in the future, if it is necessary for you to use it, you have to know that this thing exists and it is possible to do. Okay, so this is another example. This is what we're working at, the front, top, and right side. And we start with our width, height, and also depth. Start with our axis and then draw the block. And then fill in the details. Oh, this is the same thing. Sorry. Okay, moving on to oblique drawings. Okay, so we know that orthographic drawing is shows us the glass box view, and then we fold it out or we cut it out, and we get all those parallel projection planes, right? For orthographic, this is orthographic. For oblique drawing, we draw it at an angle. So how is it different than isometric? Isometric, you have that axis where the angle are 120 degrees each between each axis, right? But for oblique, it is typically 30 degrees or 45 degrees or 60 degrees. It can be other angles as well, but this is the most common angles used for oblique drawings. So typical oblique drawing, this is 30, 45, and 60 from the horizontal. So let's look at this diagram over here. Whoops. So here you have this object. The front side is parallel to your axis, and the, what do I call it, receding axis, we call this as the receding axis, is 30 degrees from the horizontal. The receding axis can also be 45 degrees from the horizontal, and the receding axis can also be 60 degrees from the horizontal. These are all oblique drawings. Oops, sorry. So how do we pick which side becomes the front side? So here they tell us a form of pictorial drawing in which the most descriptive or natural view is treated as the front view. So again, if you're trying to draw your head, the most natural view would be your face as your frontal view. If you're trying to draw a car, you would draw it from this side because that is the most natural way to look at a car. Okay, so we have three types of oblique drawings. Just now we talked about the three different angles, which was 30, 45, and 60. We're going to use 45 for our class. So there are three basic oblique drawings. So the first one is called cavalier. Cavalier is drawn true length along the receding axis. So it is full scale at the receding axis. The front side is always full scale. The front side is always full scale. But the receding line can be full scale, it can be half scale, or it can be between half and full scale. So when it is full scale, you call it as cavalier. When it is half scale, the receding axis is half scale, you call it as cabinet. And for general oblique, you can go between half and also full scale. Meaning to say you can draw it 2/3 of the actual dimension or 4/5. As long as it is more than half, as long as it is between half and full scale. So in oblique projection, the object face that is placed parallel to the frontal plane would be the one with the most features, right? We talked about this earlier. Thus, the first rule in creating an oblique drawing is to place complex features such as arcs, holes, or irregular surfaces parallel to the frontal plane. When we were discussing about isometric, we did not specify this. We were just interested on viewing the object at certain angles, right? But for oblique drawing, we care about which goes to the front side because we are trying to portray it at an angle. So for this drawing versus this drawing, we would say this is the most appropriate one to choose as the frontal plane. And comparing this guy and this guy, or these two drawings, we would say that this one is the most appropriate one as the frontal plane because we have more features over here. The features are longer here compared to this side. So this is just a short feature, this is a long feature. So we want the long feature on the front side. Here we want the part where we have the most features as our front side. Now you can look at over here, they portray this differently and you would see that this is not foreshortened. This is actually longer than it should be. This is the true scale and this is longer because it is portrayed at an angle. So in oblique drawings, it's not necessarily foreshortened all the time. Sometimes it becomes longer and very unnatural looking like this one. So in oblique drawings, dimensions lie in the plane of the surface to which they apply and unidirectional text placement is used. So this is easy for us because the text is unidirectional. They are all in the same direction as if we are reading this text. Everything is horizontal, but the dimensions, they follow the plane. So this plane is slanted, right? It has some angle from the horizontal. So this dimension also has some angle. Dimension text may need to be changed because only the cavalier oblique projection gives true depth. Now remember, our cavalier is true depth, and for our cabinet and also our general oblique, they go from half scale to full scale, right? So if you are choosing half scale, then your text also needs to be half scale for the one that at the receding axis. Okay, So how do we create an oblique sketch? Step number 1, block in the front face of the object. So we are going to treat this as our front face because this has the most features. It has the holes, it has all those gaps in between, which is very hard. So we want this as our frontal plane. Estimate distances to create a proportion sketch. Number 2, sketch depth construction lines at 30 degrees to 45 degrees. So here we are just going to choose 45 degrees. Easy for us. We just make 90 degrees angle and bisect that. We get our 45 degrees. Very easy. So let's use 45 degrees and you make your construction lines for you to draw. And then number 3, draw a line between each depth mark to create a back edge. So I think at this point you need to really do this yourself to get a feel for it. I also included a YouTube video where they drew an isometric drawing. You can find other videos that draw oblique drawings and see for yourself how they proceed to draw it manually. But again, I'm giving you the choice to do your assignment manually or using AutoCAD. And for your exam as well, I was informed that we should give you the option to do it using AutoCAD. So hopefully I will be able to teach you how to do that in AutoCAD later on. And then number 4, darken all the visible lines, including any part of the black circle that is inside the front circle. So this is just sketching, right? But at some angle. So that was oblique drawing. What you need to know about oblique drawing is that we can have it at certain angles, 30, 45, 60. The one that we're going to use is 45. The names are cavalier, cabinet, and also general oblique. It depends on the receding axis if you're going for full scale or not. And for isometric, we need to know what are the characteristics of isometric. Now we're going to talk about perspective drawings. Perspective drawing is the last one. Pictorial drawings used to represent 3D forms on 2D media in a manner closest to how we perceive the objects with our eyes. It's almost like we're taking a picture using our camera, and what we see in the picture is the perspective drawing. So terms to be familiar with include horizontal line, ground line, and vanishing point. This diagram gives us the orthographic profile view. It is simply looking at this perspective view but from the side. So it gives us the profile view. So the horizontal line is straight from the point view. So when we are standing over here, what we see is our horizontal line is actually straight from our view. Well, at least this is what they are trying to say here. And there are a lot of projectors that make up the perspective view. Okay, so this is quite technical. Let's not go over it. So in perspective drawings, oops, am I recording? Yes, okay. The view of the object can be dramatically changed simply by moving the vanishing point along the horizontal line. So let's take a look at the perspective drawing again that we saw earlier. What exactly is the vanishing point? So in this case, the vanishing point is this guy over here. So this is the road that we see, and eventually it comes to a single point where it vanishes. You don't see the road anymore. It disappears into a single point, right? So this is called the vanishing point. And at the end of the vanishing point is our horizontal line, and this part is called our ground line. Okay, so let's go back to the vanishing point. So you have this object over here. So if you were to view it from this side, from this angle, right? You are viewing it from here. So the vanishing point would be over here. But if you are viewing it head on, meaning to say just straight, so the vanishing point would be over here. And again, if you are standing over here, your vanishing point would also shift. So it shifts depending on how you view the object. So points to the right of center will reveal details about the right side of the object. while points to the left of the center will reveal details about the left side. So you can see over here, if you are viewing it from here, you would see more of the right side compared to if you were from here, you would see more of this side. It depends on what you want to look at, so you orient yourself. Okay, so here we have several different types of perspective drawings. This is called the bird's eye view, where your vanishing point is up here. It is the same line as your horizontal line, and your ground line is over here. This looks exactly the same as the perspective drawing that we saw earlier, right? The vanishing point is at the same axis as our horizontal line. But for the bird's eye view, the distance between the ground line and the horizontal line is quite big. I'm going to see later on. And then for the human's eye view, we see quite short between the horizontal line and the ground line, and the vanishing point is still on the horizontal line. For ground's eye view, you can imagine that you are laying on the road. You put your head on the road and you are trying to view this object with your head on the road. So what you see is the vanishing point, the ground line, and also the horizontal line are all at the same point. It is different compared to the human's eye view where you are standing. And another one would be that this is the last one, the worm's eye view, and this is used a lot in photography, creative photography, because it gives you the sense of something, a building being very huge. For example, this guy over here, when you try to portray a building that is very, very beautiful, you want to make it look magnificent, so you try to portray it as if you are very, very small. So it is also psychological in a sense that it makes you feel, wow, this is really, really big and magnificent. But compared to when you are trying to take a photo using a drone, you see everything as small, right? And it looks very not significant, I would say. So those different perspectives gives you a different type of feel. So that is something very interesting. And we are done with this lecture. I will see you in the next lecture using AutoCAD. Okay, take care everyone. Bye bye.